Bismillahirrahmanirrahim. Exercise 3.4, question number 2, part 6, integral e to power minus 6 sine 2x dx. The formula for integration by parts, integral fx gx dx, considering f as first and g as second function, is first function constant, integral of second, minus integral derivative of first into the same integral, and then we get dx for this integral sign. The previous knowledge which we need here is d by dx of e to power minus 6 equals to e to power minus 6 into d by dx of minus 6 by the application of chain rule. The derivative of minus 6 is minus 1. As a result, d by dx of e to power minus 6 becomes minus e minus 6. Integral of sine 2x dx equals to minus cos 2x by 2 plus c. Integral of cos 2x dx equals to sine 2x by 2 plus c. Let's start the solution. We name the integral as I. Integral I equals to integration sign e to power minus 6 sine 2x dx. We are going to perform integration by parts using e minus x as first function and sine 2x as the second. So we perform integration by parts, integrate by parts. What do I get? Integral I is equal to first function constant, integral of second, minus integral, bracket starts, derivative of first function into the same integral, sine 2x dx, bracket close, and dx. We write in the results with the help of this sidebar, and we get e to power minus 6. Integral of sine 2x is minus cos 2x by 2. So I use a bracket here, minus integral. Derivative of e to power minus x is minus e minus x. Again, I use a bracket here. Integral of sine 2x is minus cos 2x by 2. And then comes this dx. So what do I get? I get minus e minus x cos 2x whole by 2 minus this minus and this minus becomes plus e to power. We don't need to write plus here. So I get minus and minus plus e to power minus x cos 2x, and this 2 I bring it outside. This is it. 1 by 2 outside, minus minus become positive sign. We don't write plus sign here, and e to power minus x cos 2x, and then comes dx. Now let's see what I'm going to write here. I'm going to write integral I is equal to minus e minus x cos 2x by 2 minus 1 by 2 I1, where I1 is equal to integral e minus x cos 2x dx, and for further reference we are going to name this integral as integral number 1. And now what we are going to do, we are going to perform integration by parts over this integral using e minus x as first and cos 2x as the second function. So we integrate by parts, integrate by parts, and what do I get? I1 is equal to first function constant, integral of second minus integral, bracket starts, derivative of first function d by dx of e minus x into the same integral, integral cos 2x dx, bracket close, and a dx. Write the results from here and you will get e to power minus 6 sine 2x by 2 minus integral. Derivative of e to power minus x is minus e minus x. So I use a bracket. Integral of cos 2x is sine 2x by 2, and then I have a dx here. And I know that this is the last performed integral, so that is why I am going to introduce a constant of integration. You will see in the next step why I am saying that it is the last performed integral. Let's continue. I have I1 is equal to e to power minus x sine 2x divided by 2. This bring this minus sign outside and you will get plus. Also bring this 2 outside and you will get a 1 by 2 here, and we get integral e to power minus x sine 2x dx. Inside it you can check minus minus become plus, this 1 by 2 gets outside, and we get inside the integral e to power minus x sine 2x. You can check all these terms, and then I have a c1 here. Now e to power minus x sine 2x dx. Let's get back to our original question. It is equal to e to power minus x sine 2x dx, and we have named it as I. Now use its name here, and you will get integral I1 is equal to e minus x sine 2x divided by 2 plus 1 by 2 I plus a constant of integration. Now you can see we don't have any more integrations to do. So this was the last integration which we performed. That is why we introduced a constant here. Okay, now what is it? What we are going to do now? We are going to put it in result number 1. We have evaluated I1 and we are going to put I1 in result number 1. Let's see what is result number 1. I is equal to minus, this is result number 1, minus e minus x cos 2x divided by 2 minus 1 by 2, and put the value of I1 here. It will become e minus x sine 2x by 2 plus 1 by 2 I plus c1. And now open up the bracket, you will get integral I is equal to minus e minus x cos 2x by 2 minus 1 by 4 e minus x sine 2x, or I think I better write it like this, minus e minus x sine 2x whole by 4, and then minus 1 by 4 I, and then I have minus 1 by 2 c1. I have to correct it. Minus 1 by 2 into c1 becomes minus c1 by 2. Now bring this minus 1 by 4 I over this side. You will get I plus 1 by 4 I, and from these two terms I see that I can take what can I take common? I can take minus sign common, I can take e minus 6 common, and I can take by 2 common. And what about, let's see, inside I will have cos 2x, and here I will have minus is has gone outside, so here I have sine 2x by 2, and this minus 1 by 4 I has gone to this side, and I have minus c1 by 2. This is what I have. Now what do? We add these two. 1 plus 1 by 4 equals to, take the LCM and perform this addition. You will get 5 by 4. As a result, I have 5 by 4 I is equal to minus e minus 6 by 2 cos 2x plus sine 2x by 2, then minus c1 by 2. Now what I'm going to do, I'm going to multiply both the sides by 4 by 5, so that this got cancelled. This 5 by 4 got cancelled. I think I better write this all once again, because I don't have enough space for this 4 by 5. I'm just writing it again just to make space for my 4 by 5. Here it is, into 4 by 5. On this side, I'm going to multiply this whole expression by 4 by 5. So I will have to multiply by 4 by 5 here, and I will have to multiply by 4 by 5 here. Multiply this with 4 by 5 and this with 4 by 5. Okay, so what do I see here? This 4 got cancelled, this 5 got cancelled. What happened here? This 2 got cancelled, 2 ones are 2 and 2 twos are 4. And what happened here? This got cancelled with this, and now I'm going to write my answer now. Let's see. I have got integral I is equal to minus 2 e to power minus x by 5. Inside the bracket, I have cos 2x plus sine 2x by 2. And what about this one? This is going to be minus 2c1 by 5. You may perform another step and write it as c. I'm writing it directly. It is equal to c, and this is my answer. Integral I is equal to minus 2e minus x by 5 into cos 2x plus sin 2x by 2 plus c, and that completes the solution.